Right, guys, so now let's talk about Merkle trees. That's a continuation of the previous video. Okay, so why do we want Merkle trees? So the idea behind Merkle tree, okay, is to actually create a device where you can actually very quickly spot whether whether the trees, whether the data is actually reliable or not, okay? Because, for example, if you have a tree like that, okay, how can you guarantee that whatever the data that you have here, okay, is actually, the data that you started with? Let's say you have 1 here, and now I'm, as a hacker, I'm going to come, and instead of 1, I'm going to put 0, okay? And what you want to do, you want to guarantee that if somebody tampers with a tree or tampers with your data, you'll be able to catch it immediately. You'll be able to catch it immediately. So one way to do it is a device which is called serialization. So what you want to do, you somehow want to encode the data of the entire tree inside one, in one way, so that it will be actually a very efficient way, to actually see whether the data is being tampered or not. So one way to do it is what we call serialization. So how does serialization work? Let me just show it to you. I'm not going to explain it formally. Okay? Serialization is just when you have the data and you just concatenate this into a string. So for example, if you have a folder, and inside folder you have the list of files, let's say Yakov1, Yakov2, Yakov3, and Yakov4. So serialization, okay, is going to be something like that. You will take Yakov1 and you are going to concatenate it with Yakov2. And here you are going to concatenate it with Yakov3, and then you're going to concatenate it with Yakov4. That's all there is to it, okay? So if you have a folder system here, and you have files, okay, and you do not want anybody to tamper with these files, so what can you do? You can actually serialize it. Now, if I'm coming back, okay, and I'm going to say, okay, I'm now going to change this guy from Yakov1 to Yakov0, what will happen? Well, this string is going to refer to the old files, but the new string is going to be Yakov0, Yakov1, Yakov2, Yakov3, and Yakov4. You see? So now, Yakov1 and 0 are going to be different, and voila! You know exactly that somebody, changed the name of a file, okay? You don't know what file it changed. Well, now you know here because you kind of have the thing, right? So here you have an additional benefit that you know exactly what file it changed, okay? So this is called serialization. Now this is a horrible way to hold, to hold information. Why? Because here, for example, you don't know which belongs to which. For example, I can say here, Yakov1, 2, or something like that. So then it will be Yakov1, 2 here, okay? But then you can actually get confused which string belongs to which file, okay? So this is not a good way to store data. This is a much better way to store data. But this is a great device to know if somebody tampered with your data or not, okay? Now, Merkle trees are a very similar concept. But first of all, instead of serializing the folders or the file names as I did here, you are going to serialize the entire tree. And how do you serialize the entire tree? Well, it's actually very simple. Let's say you have 0, 1 here, and then you have 2, and here you have 3, and here you have 4, and here you have 5, 6. Okay? So when you serialize, you go from the bottom top. You can also go from the top bottom, okay? Nobody prevents you to do it, but, and that's how I talked about this in class, but the classical implementation of the Merkle tree is going from bottom, from top to bottom, from bottom to top. So here, for example, the serialization is going to be 0. Here it is going to be 1. Here, the serialization is going to be 0, 1, and 2. Okay? Because the 0 comes from this child, 1 comes from this child, and 2 comes from this child. Now, what about this part? Okay? So in this node, you will have 0, 1, and 2. What about this part? Well, here you are going to have 5, 6, and here 4. So the serialization will be 4, 5, 6. And when you are going to here, it is going to be 0, 1, 2, 3, 4, 5, 6, for example. Okay? So the serialization on the left-hand side comes first, then comes the node, and then comes the serialization in the right-hand side. So if you think about this, okay, we had basically for quicksort, we had print left, print node, print right. Okay, so when you want to serialize, you can say, okay, serialize left, concatenate with node value, okay? Maybe I'll use another color. So serialize left, concatenate node, and then concatenate serialize right. Okay, and once again, if you are touching any one of those guys, just like with the subfolders, right, you can actually say that you know that somebody tampered with your data. So for example, here, it is going to be 0, 1, 2, 3, 4, 5, 6. Now here, I'm changing it from 0, I'm changing it to 20, for example. So then it is going to be 20, 1, 2, 3, 4, 5, 6. And you can see that this and this are different. Okay, so you know that somebody tampered with your data. Once again, it is a horrible way to organize data because these are strings. You don't know, you cannot find your legs. You don't know here, right, if it's 0, 1, 2, 3, 4, 5, 6 came from this node, or maybe it was, 1, 2 here, so, and 0 here, so you have 0, 1, 2, 3. I mean, you can see that it's not a good way to organize data, but it's a very good way to see if you're tampering with the data or not. If you tamper with the data or not. Okay? Now, suppose you do not want to expose the content. Here, the problem with this serialization is that you kind of expose the content of the tree. Okay? Now, for security purposes, as we talked about, if you don't want to expose the content. So what do you do then? Well, then you use cryptography. As we described in class, there is this concept of trapdoor function. Okay, where you have data, this is your data, and you apply this function, you get a mumbo jumbo string. It is very hard or almost impossible to go from this string to the data itself. It is impossible. I mean, it's possible, and maybe you guys can discover how to do it, okay, because we do not have a mathematical proof that it's impossible. But until now, the best minds in computer science, best minds, best mathematicians, blah, 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 couldn't do it. Anybody that can do it, he is going to become very rich, and he's going to hold the world, or at least the security, in his hands. I cannot say in a public video what he's going to hold of other people, but you can actually imagine what he's going to hold. Okay? So this is called, now an example function like this is called SHA. Now I told you, okay, for laymen, you can think about this as being, for example, something like this, okay, that if you have a number x, it is very easy for a layman to square it. Anybody can square it, okay? Everybody knows that 5 times 5 equals 25, okay? But to take the square root for a layman and not for computer science as a mathematician, because they will laugh. They watch these videos, they will laugh into my hands and say, oh my God, what you're talking about, taking square root is very easy if you know the Newton method, right? But it's somewhat non-trivial for people from, from business community or CEOs. You give them 5, they will square it. But, you ask Bill Gates what's the square root of 5. Oh my God, oh my God, oh my God, right? Well, maybe Bill Gates knows, but somebody else doesn't know. Okay? Is this clear? So, this is easy, but the reverse is much tougher. Okay? This is exactly the same story, but it's now much more sophisticated because it's not just for laymen, it's for the smartest people in the world. So, if you give the data and you apply the SHA function, you will get a mumbo-jumbo string. Now, here, okay, another way to get, one more step to get to the Merkle tree is just to take a SHA. Okay? So what you do now, instead of taking 0, 1, 2 here, you will take a SHA of 0, 1, 2, okay? And here, you're going to apply a SHA to 0, 1, 2, and 3. So basically, you're just going to make sure that it's mumbo jumbo, mumbo jumbo, right? Nobody will be able to guess it. Now, if you start with the same data and you're applying these SHAs, okay, sequentially, you'll get the same data at the end. Okay, you'll get the same SHA at the end. However, if I tamper with the data here, okay, and I will get a different SHA. So if I will get a different SHA, I know that the data has been tampered with. I don't know where, and I don't know how. Okay? I know that it's been tampered. Right? Now, this SHA algorithm, this Merkle tree algorithm, okay, is the heart of Bitcoin. Now, the one thing that Bitcoin has, instead of having a binary tree, it has a very simple list, like this. Okay, in each list, in each element of this list, right, just like a tree, it contains transactions. But it will also contain a SHA that will be basically a SHA of everything that came before that and this guy. So how does Bitcoin work? Exactly, we're going to explain in the next video. We're going to discuss it next lecture, okay? But just to make sure that you understand that the Merkle tree, that there is a direct linkage between Merkle tree and this kind of lists that Bitcoin has, and this, because each list contains transaction, it is called a blockchain. But in reality, if you have a folder system, right? Let's say that here you have one folder, contains a lot of stuff. Now there is another folder, so it has files, plus maybe it has subfolder. So this subfolder contains also files and some other subfolders. Okay? You can think about these subfolders as being basically the blocks. And then the files will be kind of the transactions which corresponds to, which somehow correspond to Bitcoin, to financial transactions, which is what Bitcoin is. Okay? And then if you apply, now here you have only one subfolder. That's what will correspond to Bitcoin, to this list. If you have more than one subfolder, then it's going to be a blockchain tree if you want. Okay? And there are people that are using blockchain tree, but we are not going to talk about this right now because we are not interested in the nitty-gritty stuff of how blockchain works yet. We will be interested a little bit later. Okay? So, I hope that this kind of clarifies what Merkle trees are, what lists are, and we also about SHAs, right? It's these functions that one direction is easy, another direction is hard, okay? And it kind of clarifies what's going on with all this technology that was invented by Satoshi. So basically what we're doing, we're looking on these small pieces of puzzle. And the genius of Satoshi was that he actually put them together. He didn't use anything that wasn't known before. The brilliance of this guy was that he realized how to put all these things together in order to create a decentralized system that actually kind of secure. Okay, and we're going to talk about this next lecture. Okay, so have a great weekend, and I'm going to pause these videos, and I hope that you guys will enjoy watching them. Okay, thank you, and have a great day.